Hi everyone, welcome back to another episode of Matrices and Determinants brought to you by your host, Sage, your smart and genius educator. So today we're going to continue our marathon with matrix operations, that is addition, subtraction, and multiplication of matrices. So we are going to start off with addition of matrices. First of all, before we continue, for your addition and subtraction, you can only add and subtract matrices of the same order. For example, let's say you have 2 by 2 matrices. Then both of them must be 2 by 2 for you to add them together and or subtract them. If the matrices are of different orders, then you can't add. You won't even say your answer is 0. You say it is not possible to add or subtract. So let's start with this example. We are given two matrices, A as this and B as this. As you can see, they are of the same order. This matrix A, we have 2 rows and 2 columns. It's 2 by 2. And our matrix B is also 2 by 2. So it is safe to add these two matrices. So the way you add and subtract matrices, you simply add and subtract the entries. That is, you add and subtract by the position. How do I explain it now? If you want to find A plus B here, the way you are going to add them, you simply add the number in the first position in A, you will add it to the number in the first position in B. The number in second position in A, you add it to the number in the second position in B. Just be adding them according to their entries, according to their positions. So if you want to add here, you'll be simply doing 2 plus 1, which is 3. Then 3 plus 2, which is 5. 4 plus 3, which is 7. And 5 plus 4, which is 9. This is our answer. Very easy, right? Alright, so let's move over to subtraction of matrices. Like I said earlier, if you want to add or subtract matrices, the matrices must first of all be in the same order. So let's check out what we're asked to subtract here if they are the same order. They are. This is a 3 by 3 matrix in A, and also B is another 3 by 3 matrix. So let's subtract them. Just like the way we did addition, you are subtracting according to their entries or according to the position. So you are doing 1 minus 3, and 1 minus 3 will give us negative 2. Then you are doing 0 minus 5, and 0 minus 5 will give us negative 5. Then you are doing 2 minus minus 1. 2 minus minus 1 is like saying 2 plus 1, which will give us 3. Then move over to the second row. You are doing minus 1 minus 4. Minus 1 minus 4 will give us negative 5. Then 3 minus minus 2. 3 minus minus 2 is like saying 3 plus 2, which will give us 5. Then we have 4 minus 0. 4 minus 0 will give us 4. Now over to the last row. In the last row, we are going to be doing 2 minus 1. 2 minus 1 will give us 1. Then 1 minus 2. 1 minus 2 will give us negative 1. Then minus 2 minus 3. Minus 2 minus 3 will give us negative 5. So in conclusion of addition and subtraction of matrices, before you start, you must first of all check your two matrices if they are of the same order. If no, do not attempt it. It's not possible. Then if yes, you simply add and subtract according to the numbers in their entries. Alright, so moving on to multiplication of matrices. It's a bit more complex than addition and subtraction. The rule for adding and subtracting matrices is that they must be of the same order, but the rule for multiplication is quite different. So we are going to I'll start off by explaining how do you know when two matrices can multiply each other. Alright, let's give an example. Let's say we have a matrix A. Our matrix A, the order of that matrix is 2 by 2. And we have another matrix B, and the order of that matrix is also 2 by 2. Now, how do you know if the matrices can multiply? Like I said, A is 2 by 2, B is also 2 by 2. They can multiply if the ending here is the same as the beginning here. That is, in A, if the number of columns is equal to the number of rows in B, or to leave plenty English, the ending here, if it's equal to the beginning here, then the two matrices can multiply, such as this one now. The end is 2 for A, and the beginning in B is also 2. So since they are the same, they can multiply. And then your resultant matrix, when you've multiplied them, the answer you are going to get, since these two are the same, they can marry off and they can travel to start their own family. So you will now be left with this one and this one. So that means our resultant matrix should be giving us a 2 by 2 matrix. Another good example is if you have a matrix A as a 2 by 3 matrix and a matrix B as a 3 by 4 matrix. These two matrices can also multiply. Look at it. A is 2 by 3, B is 3 by 4. The end here is 3, the beginning here is 3. They are the same, so that means the matrices can multiply. These two can marry, start their own family, so that means your resultant matrix will be a 2 by 4 matrix. Then another example you can have is if you have a 2 by 3 matrix multiplying another 2 by 3 matrices. Multiplying another 2 by 3 matrix. These two matrices cannot multiply. Look at it. You have 2 by 3 here. You have 2 by 3 here. As you can see, the end here and the beginning here, they are two different numbers. They will not agree in their marriage. So these matrices is not possible to multiply them. So let's give an example whereby we multiply our matrices. So let's start off with this example. We are asked to multiply these two matrices. So like I said, let us first of all check if they can multiply each other. Now, let us check for our order here. In A, our order is number of rows 1, 2, 2 by number of columns 1, 2, 3. Our A is a 2 by 3 matrix, and our B is also a 2 by 3 matrix. Now, as you can see, the number at the end here and the number at the beginning here are not the same, so they cannot marry, meaning that these two matrices cannot be multiplied. So what you can just conclude in your answer is that it is not possible to multiply A and B. Alright, so let's move over to example 2. We are asked to multiply these two matrices. So first of all, let's check if they can multiply. As you can see, our A here is a 2 by 2 matrix, and our B here is also a 2 by 2 matrix. Now, the last number here and the first number here are the same, so they can marry off, start their own family, meaning that the two matrices can multiply, and our resultant matrix should be 2 by 2 matrix. So let's multiply now. We are asked to do A multiplying B. Now, since you know they can multiply, the way you do matrix multiplication, you do row multiplying column. That is, in A, you do the first row in A multiplying the first column in B, then move over to first row multiplying second column, then you go to second row in A multiplying this. Now, what I mean by that is, first of all, you start with the first row in A multiplying first column in B. It will be this times this plus this times this. That is 2 times 1 plus 3 times 3. This is your first entry. Then you are done with first column. You will now use that same first row to multiply the second column. That is, you are doing 2 times 2 plus 3 times 4. So the second entry here will be 2 times 2 plus what? 3 times 4. Now, you move over to second row. You do the same thing for the second row. You first of all use the second row to multiply first column. then use the second row to multiply second column. So in the second row, you'll be doing 4 times 1 plus 5 times 3. That's 4 times 1 plus 5 times 3 here. Then the other entry, it will be 4 times 2 plus 5 times 4. 4 times 2 plus 5 times 4. Good. As you can see, these entries is this is going to give us a 2 by 2 matrix, so our resultant is going to be correct. So if we multiply here, 2 times 1 is 2, 3 times 3 is 9, so 2 plus 9, this place should give us 11. Then here, 2 times 2 is 4, 3 times 4 is 12, so 4 plus 12 should be giving us 16. Then down here, 4 times 1 is 4, 5 times 3, 15. So 4 plus 15 should give us 19. Then 4 times 2, 8, 5 times 4, 20. 8 plus 20 should give us 28. So this is our answer after multiplying. Alright, so let's take one final example on multiplication of matrices. We are asked to multiply these two matrices, so let's check if they are eligible for multiplication. This first matrix, 1, 2, 1, 2, 3. The first one is a 2 by 3 matrix, and the second one, the B, 1, 2, 3, 1, 2, is a 3 by 2 matrix. Now as you can see, the last number here and the first number here are the same, so these two matrices can multiply. And our resultant matrix will now be a 2 by 2 matrix. So let's go ahead and multiply. Now, like I said earlier, the way you multiply matrices, you do it row multiplying column. So now we're going to be doing first row in A, multiplying first column in B, then multiply second column. Then we'll now do second row in A, multiplying first column in B, multiply second column, and so on and so forth. So we're going to, let's do the first row in A, multiplying first column in B. So you are doing 1 times 7 plus 2 times 9 plus 3 times 11. So this is 1 times 7 plus 2 times 9 plus 3 times 11. Okay? Then, now you go ahead, use the same first row to multiply the second column. So here you will now be doing 1 times 8 plus 2 times 10 plus 3 times 12. 1 times 8 plus 2 times 10 plus 3 times 12. We are done with our first row. Now moving over to our second row. You do the second row to multiply first column, then use it to multiply the second column. So you are going to be doing 4 times 7 plus 5 times 9 plus 6 times 11. 4 times 7 plus 5 times 9 plus 6 times 11. Then use it to multiply the second row. That's 4 times 8 plus 5 times 10 plus 6 times 12. 4 times 8 plus 5 times 10 plus 6 times 12. Now as you can see, this is going to give us a 2 by 2 matrix definitely. So our resultant matrix is going to be correct. So let's multiply now. Now we have that 1 times 7 is 7 plus 2 times 9, 18 plus 3 times 11, 33. Then here, 1 times 8 is 8 plus 2 times 10, 20 plus 3 times 12, 36. Now down here, 4 times 7, 28 plus 5 times 9, 45 plus 6 times 11, 66. Then 4 times 8, 32 plus 5 times 10, 50 plus 6 times 12, 72. So this is equal to, this place here will give us 58. Here, adding these together, 420, 64. Here will give us, this should be 139. While here, will be 154. So this is our final answer. So in conclusion, addition and subtraction of matrices, to add and subtract, they should be of the same order. While multiplication, the end of the first matrix, the beginning of the second, that's in the order, the ending, the last number in the first matrix, and the beginning and the first number in the second matrix should be the same before they can multiply. And the way you multiply them, you are doing row multiplying column. So please like and subscribe to my channel so you can see more on matrices and determinants. In our next video, we are going to learn how to find the determinant of matrix. Bye guys, Sage out.